Welcome to Module 2, Security Requirements Gathering. Requirements gathering has been a part of software and systems engineering for many years, but here we're focusing on adding security requirements to that matrix so that while you're gathering your other requirements for functionality and purpose, that you'll also gather security requirements. Now, our objectives in this module are as follows. First of all, we want to make sure you fully understand the importance of gathering security requirements, why this is so critical to secure programming. We want you to understand the entire process of security requirements engineering and its phases. It's common for many software developers to not fully understand requirements engineering in general, much less security requirements engineering. We want to look at what are called abuse cases and abuse case modeling. That's a tool that lets you visualize the attack vectors and do threat modeling. We're going to describe security use cases and security use case modeling. That's the opposite side of the abuse case modeling. We're going to look at the actual abusers. By abusers, we mean the threat actors, those people who might abuse your system to compromise your security. We're then going to explain security quality requirements engineering. That's a model commonly called SQUARE. The idea is to ensure that we have a high quality of security throughout our requirements engineering process. We want to look at operational critical threat, asset, and vulnerability evaluation. That's a model commonly called Octave. The SQUARE and the Octave models both work in conjunction to help you get a really good understanding of the security needs for your system. So why is it important to do security requirements gathering? First of all, what are the software security requirements? These are not the functional requirements. Functional requirements are the general purpose of your software application. What is it we want the application to do? Security requirements are non-functional. They're there to maintain that confidentiality, integrity, and availability of the application, the CIA triangle. Now, stakeholders sometimes overlook the whole issue of security requirements gathering. As we've stated in previous modules, it's often the case that security gets tacked on during the testing phase or sometimes even after deployment. So requirements gathering often skips the security requirements. We want to correct that issue. Now, failure to do this, negligence in this area, will lead to security vulnerabilities being introduced into your application. Now, you may find those later during testing, but the first problem with that approach is it will be more costly, both in time and dollars, to correct errors then. The second problem is, note I said, you may find these vulnerabilities later. You may not. You might not find them until deployment, until end users are being hit with these attacks. So security requirements gathering, this is how we implement security from the very beginning of our software development lifecycle. Now, gathering security requirements should be a part of all strategic application development process. In other words, every application you develop should include security requirements gathering. How do we do this? Well, unfortunately, as I stated earlier, a lot of developers don't have a good grasp of requirements gathering. One of the issues that you hear in good software and systems engineering courses is requirements elicitation. And that's even more important in security requirements. What this means is I'm not just expecting the end user and the stakeholders to tell me everything that's needed. I expect to have to use a process to elicit from them their needs. They don't know what to ask for. They're not professional developers, and they're absolutely not security professionals. So they're not even sure what they should require. So if your expectation is to passively sit back and take note of whatever the stakeholders tell you, that's not how this is done. We're going to look into how to elicit those requirements. This has to be separate from the functional requirements so that you can review and test them separately. Now, separate doesn't necessarily mean at different times. You might do the requirements at the same time, but you track them separately. You might test them at the same time, but the test results are evaluated separately. If you don't do that, if you mix functional and security requirements, things get very complicated very fast. And it becomes unclear what part is a security requirement and what part's a functional requirement. And it's difficult to track which area you need the most focus on. Why we need a different approach for security requirements gathering? Well, first of all, functional requirements are positive things. What would you like the software to do? I would like it to communicate wirelessly. I would like it to connect via Bluetooth. I would like it to facilitate sharing videos with family members and friends. Those sorts of things. Security requirements are negative. I don't want it to do things. I don't want my wireless communication to be sent in the clear. I don't want someone to be able to Bluetooth pair with this application without my acknowledgement and permission. I don't want those pictures and videos to be shared with third-party people that I don't know. So this negativity is a very different approach. We're looking at what the software should not do. It's really against the natural tendency of people to think this way. When you're thinking about a new software project, you're anticipating specific needs you want it to fulfill. So for example, if you work for an insurance company, and this is a new web application that will streamline the process of customers applying for new insurance policies or renewing policies, well, what you're thinking about, what your stakeholders are focusing on, are all the positive things it could do. So if we do a requirements elicitation alongside the security requirements elicitation, there may be some thought process issues. People are not thinking of the negative. So while it's not absolutely required, it's frequent to do the two separately. To do security requirements, you need to look at the software in a very critical, destructive way. Put more simply, you should look at your software and think like a bad guy and ask yourself, if I had ill intent, with all my knowledge of programming and of computer science in general, and all my knowledge of this specific application, if I had ill intent, what would I do to compromise this application? And that can be the basis of beginning security requirements elicitation. Now, what are the key benefits of looking at security this early on, not waiting till later? First of all, it saves a huge amount of money on every project. And various estimates include billions of dollars a year throughout the entire national economy being wasted through trying to fix things later that should have been handled early in the development life cycle. If you think about security requirements from the beginning, then your entire development team can focus on key security controls during the programming and implementation process. This will also specify security mechanisms that have to be in place in the application. Let your programmers again focus on what they need to put into the code while they're writing code. Correctly understood security requirements can help in implementing security in the subsequent stages. So if you do security requirements gathering appropriately, security design is going to be easier, secure implementation will be easier, and secure testing will be easier. Now you need to get other people involved than just the developers. This is true with normal requirements gathering, with functional requirements gathering, and it's also true with security requirements gathering. This means end users. Who's going to use this product? What are their concerns? Any customers, business sponsors, of course developers, and any requirements engineers you have. If you have access to security experts who can provide you insight into the latest attacks and to how to mitigate those, that would be helpful as well. And of course, your project managers and architects may also have some insight onto the requirements gathering process. Characteristics of good security requirements. There's an acronym, and you'll see several of these acronyms throughout the course to help you remember this. It's called SMART. First of all, requirements have to be specific, clear and precise. For example, if you say, I want my application to be more secure, that's vague. I don't even know what that means. I can't implement that. But if you say, I want to ensure that my application filters input and is not vulnerable to SQL injection, that's specific. That can be done. Measurable. Well, this goes hand in hand with specific. Is it possible to measure and test your requirement? If it's too vague, you won't be able to measure and test it. Actionable. Can a programmer look at your requirement and actually do something? Again, this goes right back to the specificity. If a requirement is not very specific if it's not clear and unambiguous, then they're not going to be able to implement it. We need to make sure this is something that a programmer can take action on and accomplish. Realistic. Ideally, we would have unlimited time and unlimited budget for every program, but we all know that's not true. So can your requirements be done realistically with the budget and time constraints you have? And timely. You should understand which requirements need to be implemented first and which are of most importance. Security requirements can get broadly classified into a few areas. One is functional security requirements. These are specific to the particular business issue that the software is trying to handle. Input validation, strong passwords, authentication, things of that nature. And security drivers. These are a process by which you comply with standards, policies, regulations. For example, medical software in the United States has to comply with both HIPAA and HITECH. Financial software that processes credit card data must comply with PCI DSS. So these are the drivers for your security. Now, I do want to be clear on one thing. Security standards are not the ultimate goal in security. They're the baseline. So if you're developing medical software and you fully comply with HIPAA and HITECH, that doesn't mean you're done. That means you've got the base covered. You've got the fundamentals, and now, if possible, you'd like to exceed that. So let's talk in detail how you do security requirements engineering. The idea is to get actively involved in engaging all the stakeholders, including users and security experts, to elicit from them what their security requirements are. It's a systematic approach to identify, analyze, elicit, and specify all the security requirements for any software system. This is a major part of any software development lifecycle process. One of the very first things you do in security requirement engineering is that elicitation. First of all, look at the functional requirements of the software. What is it supposed to do? Now, this is another reason to do functional requirements and security requirements separately, because you need to know what the functional requirements are in order to then do security requirements. Once you've analyzed those functional requirements, identify relevant stakeholders, gather the security expectations for the various functions of the system. In other words, I have a part of my program that allows people to log in. What are my security expectations? Is there a certain number of attempts before we lock people out? Is there a password age that I require? Password rotation, complexity requirements. All of these are requirements on just one thing, logging in. Use different elicitation techniques. You can try questionnaires, and those are sometimes helpful. You can get people together into a brainstorming workshop where people throw out ideas. Now, I personally find that often very helpful because one person's idea will often trigger other people to have additional ideas. Storyboarding is also helpful. What if a person tries this? What do we want to happen? Those kinds of things. And that will go hand in hand with the abuse cases we'll talk about in just a little while. The whole idea is to do a requirements analysis that gives you a blueprint of what your security requirements are as early as possible. So you look at all the aspects of security requirements that you gathered during that elicitation phase. What did you get out of those brainstorming workshops, questionnaires, and storyboarding? Look for any conflicts or ambiguity. In other words, someone may have a security requirement that completely conflicts with a functional requirement. A great example is Bluetooth. Bluetooth, by definition, allows the device and service to be discoverable. If someone were to suggest during requirements gathering that the device must be Bluetooth enabled, and then another party during security requirements says the device's services should not be discoverable, well, that's a conflict. And you need to address that with the various stakeholders and see if it can be sorted out. Make sure there's no ambiguity. Early as possible, we want to make sure our requirements are clear, actionable, concise, no ambiguity at all. Now, another thing to look at is completeness. Did we cover everything? Again, we're looking at other stakeholders to give us input, but at the end of the day, it's up to us to make secure software. So we may look at the requirements we got from requirement solicitation, and we may identify gaps that we fill in ourselves. As long as what we put in doesn't conflict with the functional requirements, that's actually a very good idea. Now, make sure that the requirements meet the stakeholder's expectation. One of the things that doesn't get discussed enough is managing customer expectations, in this case, stakeholder. They may be expecting things that are not possible. For example, if someone were to tell you, I need this application to be 100% guaranteed that no one could ever hack it, I can't deliver that, and neither can anyone else. The only way I know to make an application completely unhackable is to ensure that it has absolutely no data, no functionality, turn it off, and close the machine. And that's not very useful. So that might be an expectation that the stakeholder has that's unreasonable, and you need to address that now, not later when they're terribly disappointed. The requirement specification part is integral to the entire requirement engineering process. We look for actions in our requirement specification. We organize the security requirements in such a way that they can be clear, consistent, and traceable. Now, that traceability is interesting. Throughout software and systems engineering, there are a number of tools that are used in traceability. My personal favorite is the bidirectional traceability matrix, and it's literally simply a grid that has a list of requirements and then shows where in the final product they were implemented. And it's called bidirectional because every requirement should be traceable to a function of the final software, but every function in the software should also be traceable back to an initial requirement. You don't have extra things that were added that weren't needed. Document all of the security requirements. Now, documentation is something many developers don't enjoy, but it's a critical part of good software engineering. The security requirement management phase means that we look at all the things that we've gathered and documented, and literally we manage them. We may need to update security requirements. This is a process over time. We may discover that there are new vulnerabilities that are an issue, or old vulnerabilities that are no longer an issue. Perhaps you were using a DLL or a library that had some flaw in it, and that was an issue you needed to address, but now there's a new version of that library that doesn't have that flaw. That's one positive example how requirements could need to be updated. So we start with requirement solicitation. That's essentially finding creative ways to ask all the relevant parties. Then analysis is looking at what we got from that requirement solicitation and making sure they're concise, complete, not contradictory, and actionable. Requirement specification is where we put these together and make specific requirements that the developers are supposed to implement. And then requirements management is how we look at all these requirements and ensure that things are done properly, updated as needed, scheduled, prioritized, those sorts of things. So these are basically 4 phases of security requirements engineering. Now, there are quite a few different models for doing this. A derived approach is usually a traditional requirements gathering approach where you have use case models. We'll see some of those in a little bit. And we look at security requirements in the development process. A dedicated approach means you have a specific approach just for security requirements. Put another way, the derived approach kind of tacks security requirements onto functional requirements. The dedicated approach has an entire separate process just for security requirements. Now, I'm not saying either approach is wrong, just make sure you had a conscious decision to use one approach or the other. Let's talk about the abuse cases and security use case modeling. Abuse cases are one of my favorite ways to discuss security, particularly application security. We look at ways a person might misuse the system. Now, the slide here is using something not software, but easy to relate to. We're looking at a car. Now, a user, a legitimate user, might drive the car, lock the car, things of that nature. An abuser, a thief, might steal the car, short the ignition, things of that nature. And so what we can see here in this abuse case diagram is it lets everyone see how a bad actor might abuse specific parts of the car's functionality to accomplish things we don't want them to do. One of the reasons I like this is it's so easy to communicate to anyone what the issues are. And I take this back to those workshops we discussed a little while ago. Putting a few abuse cases up on a screen will facilitate people's thought processes about how a bad guy might abuse the system. Threatens relationship. That is a particular connection between an abuse case and a use case. It basically says, on the one hand, we have this use case, the way it's supposed to be used. Then we have an abuse case which threatens that use. This is a type of relationship between objects. Now, as we're going to see, abuse cases are borrowed from the UML diagram use cases. UML is Unified Modeling Language. And UML use cases and other types of UML diagrams depend on relationships. So in the abuse case, it's the threat relationship that's most important. How might the attacker abuse the system? There are some steps. We can start with simple brainstorming, doing all of these abuse cases, how a person might abuse the system. This might be done at the same time you do functional use case requirements. Then you have to analyze both the use and the abuse cases to capture functional requirements. Next, in step 3, is something I've already mentioned. Think from the adversary's perspective. If you were a bad guy, how could you misuse or disrupt this system? What are ways that you could misuse what was intended for legitimate users? Identify the actor. What actor are you concerned about? Now, this is something we've touched on in previous modules, but it's really important. Different actors have different motivations, different skill sets, and they're going to come at your system in different ways. Someone who's strictly out for financial gain, with no personal motives and no vendetta against your organization, there's a point at which they will give up simply because there's easier places to hack. On the other hand, someone who is ideologically motivated or a nation-state actor is probably not going to give up because they have a different motive than simply financial. That's just one example of how you should understand who the malicious actor is. Identify, specify, and define the exact abuse cases. It's not adequate to say, a bad guy might break into my system. A specific bad guy might break into my system in this manner, abusing or threatening these relationships in my normal use case. That is how we do it. We get that specific. Build an abuse case for each and every use case. Now, you might not immediately see how someone might abuse a particular use case, but I am confident that if you give it enough thought, you and your team will come up with abuse cases. Check for granularity of detail. Now, what I mean by that is very simple. It's pretty easy to get the broad strokes. Someone might do a SQL injection. But let's get detailed. That's what I mean by granular. Let's find out exactly what specific SQL injection attacks they might try. There are more than one way to do SQL injection. Did we account for all of them, or at least the most likely? And that goes hand in hand with the last step, which is check completeness and minimality. Now, what I mean by this, first of all, completeness. Did I cover everything? Minimality. Did I reach the minimal level of requirements for a usable functional system? Now, there are some advantages and disadvantages to abuse cases. The advantages is it's easy to learn and use these. In fact, I find non-technical users have virtually no problem mastering this technique. Abuse cases really help a lot during requirement gathering phase. And again, that's one of my favorite tools. Now, some of the disadvantages. Some people believe that abuse cases can only be used with object-oriented software. And it is true that abuse cases are a modification of use cases, which are a type of UML diagram which is designed specifically for object-oriented programming. However, with just a little bit of modification, you can use abuse cases with non-object-oriented programming. Of course, that shouldn't be a big issue today when most programming languages are indeed object-oriented. Abuse case models may not specify the detail about the relation between the use case and abuse case. They're meant to simply identify there is a relation, but they can't get that detailed. You saw the very clean-looking diagrams. If we put every detail possible there, they're no longer clean-looking diagrams, and they're far less effective. What you see now is a template for an abuse case. Now, you may or may not use all of these specific fields, but this is a good place to start. We give it an ID, a name, priority. Now, some of the things you can see are filled in here for you, so let's look at the ones that aren't. Development environment. Well, that's pretty simple. What development tools are you using? What programming languages? What code control system are you using? Are you using SVN for code control or something else? Scope. Does this apply to specific parts of your application or the entire application? Description. Now, this is free-form. Put as much detail as is necessary for someone else to understand this abuse case. Preconditions. Does something else have to be there for this bad action to take place? In some cases, there will be preconditions. In others, there may not be. Any assumptions? What do you assume? Do you assume that the user must have some level of network access in order to execute this? Or do you assume a complete outsider could do this? Postconditions. After they've done this attack, if they're able to successfully abuse the system, as per this abuse case, what's the condition that's left afterwards? Potential misactor profiles. This may be the most important part of this. Who is it you think are the actors that would abuse the system in this particular way? You can also see other items in here, related use cases, related threats, and finally, architectural recommendation. Now again, you don't have to use this specific template, but it is a good one, and if you don't have a better one, I recommend you use this one. Security use cases. Now, we looked at an abuse case that said, look, here's what a bad guy might do. And we developed those from looking at use cases. Here's what a good guy probably will do, and now we see how a bad guy might misuse that. Well, then we go to the next step, security use cases. Looking at that abuse, what will you do to mitigate that? What are the security things you can do that would make that abuse less likely or less effective? Security use cases, as we said, get driven by the abuse cases. Your security team will start with an abuse case, and from there, look at security requirements and security uses. So you always have the idea of how might the system be abused, and that drives what security measures you're going to implement. And you're always looking to protect and mitigate any sort of threat. How do we do modeling for use cases, for security use cases in particular? First of all, as we said, we analyze the possible abuse cases for this system. What are the ways a bad guy might abuse the system? Then we identify what steps are required to mitigate each and every one of those abuse cases. And this is a place where that granular view is going to be helpful. We can't be too broad. We need to get down to specifics. Include what are called mitigation mappings, which show here's a security use case. It's being done to mitigate this specific abuse case. And then you give yourself a generalized use case model that shows use, misuse, and mitigation. Now, we looked earlier at the threats relationship or threatens relationship. Now we're looking at the mitigates relationship. And this is how we connect security use cases to abuse cases. The mitigates relationship can portray how can you avoid the impact or mitigate the impact of a specific abuse on a particular system. What is your countermeasure? Now, this chart's very helpful in looking at the differences between abuse cases and security use cases and looking at their uses, evaluation criteria, who creates them, who uses them, the actors you're concerned about, and what drives them. So if you look at this chart on the screen now, this helps clarify the difference between abuse cases and security use cases. So let's talk about the advantages and disadvantages. Security use cases. The advantages are numerous. A few of them that come to mind are large applications can use primarily the use cases. Large or small can use them, but a large application might just use security use cases. Most of the security use cases depend on very scientific and precise methods to define security in the system. Disadvantage, well, it's not that these cannot be used for small applications, but they weren't really designed for that, and that might be a problem. There are possibilities of architectural and design issues in the systems that are implemented when you're looking at these security use cases. So just to keep this clear, you can use a security use case anywhere you wish, but smaller applications are more likely to be cumbersome using this process. Here we see a specific template for a security use case, just as we earlier saw one for an abuse case. And all of our fields here are filled out. You see preconditions, postconditions, what's the normal course of events, what's the alternative courses, are there any exceptions, any assumptions? All of these things are carefully thought out and planned in your security use template. Some guidelines. Use cases specify the vital requirements needed for development of the application. Put another way, we assume your programmers do know how to program. So use cases don't have to be hyper detailed, showing things that everyone would know. For example, a login screen. You don't have to define click the login button. You can simply have the process of login. Any developer knows that includes enter username, password, and click the button. Always ensure that use cases do not include any architectural mechanisms. In other words, the specifics of the architecture. This gets to a broader issue with the use case diagram itself. Use case diagrams are not only architecturally independent, they're programming language independent. I don't care if you're doing a 3-tier application, a single-tier app, you're using Java, .NET, whatever. The use case simply says, here's how we're going to use the system. So you need to avoid those things that are tied to specifics. Create a base security case for certain types. For example, you might have a base case for all logins. And then if you need to be more detailed on a specific login, you can. Always document the threats and risks with the help of these use cases. You're looking at the use case and asking yourself, what are the risks to this system? That sort of thing. Make sure you know the difference between user and misuser interactions, and make sure that's clear in all your diagrams and requirements. The security use case should provide different scenarios for externally visible actions from those which are hidden. In other words, there are things which end users can see and do in your application. There are other things in the background that might involve your application interacting with a database or a web service or something of that nature. Make sure it's clear in your security use case whether you're looking at externally visible or not externally visible. Always ensure to clearly document both the pre and post conditions for every security use case. Now right here we see an example use case for an online bidding system. And you can see on the far left the use case defining how this should be used. Creating accounts, searching for items, placing bids, changing password, that sort of thing. Then we look at a security use case which ties the use case to, on the far right, an abuse case. For example, the abuse case includes denial of service, stealing credit card details, wiretapping communications, and the security use case mitigates those with things like block repeated registration, encrypting messages, authentication, that sort of thing. So this particular screen really helps to clarify the relationship between these three types of diagrams. And here we're highlighting specifically the abuse case. So you start with the use case, you then make an abuse case, and then you create the security use case that mitigates or absolutely prevents the abuses that an attacker might execute on your system. Now here's a second example for an ATM system. And again, we have a basic use case scenario where they're depositing or withdrawing funds, getting balance, transferring, that sort of thing. Then we have abuses. Someone might invade privacy, commit fraud, spoof a user, any of those things. And those are mitigated by very specific security use cases. So again, we see the relationship between the three different types of diagrams. A third example, this is for an e-commerce system. Now there are different uses here, and in fact there are two different users being specified, but we have the exact same process. We look at the standard uses like order goods, register customer. We compare those to abuses like steal credit card information, obtain a password, and we mitigate those with our security use cases, block repeated registration, encrypt messages, things of that nature. The effectiveness of abuse and security use cases. Well, during requirements elicitation, these can really help for people to understand what requirements we've already identified and, of course, identify gaps. Helps for brainstorming, I mentioned that earlier. Doesn't need a whole lot of stakeholder identification. In other words, I'm looking at a generic user, not a specific person, and I can apply this to lots of users. The customer can be as involved or not involved as they wish to be because these are easy to understand for non-technical users even. This helps us elicit requirements other than just the security. We can get functional requirements as well using use cases. It's an iterative process. We use this to brainstorm, then we update our use cases with the proceeds of the brainstorming, and we might do the whole thing all over again. This is also usable during requirements analysis. I can look at my use cases, security use cases, and abuse cases to perform internal and external analysis. It helps me remove any ambiguity. It provides me with better clarity. And it also helps me to define specific security requirement conflicts. And we continue with other advantages and disadvantages. Now, it's not the case that this is an exhaustive list or that you have to memorize this list, but it is best if you look through it and ensure that you're comfortable with the various requirements, specification, and requirements management applications of both abuse and security use cases. Stories. Now, this may sound like an odd thing when we're talking about engineering, software engineering, but just telling stories. You literally have a story that's a written story from the point of view of the attacker. What would they do looking at your system? Now, this is really great for both security requirements gathering and management. It's really great for communicating risks. You may require additional budget to mitigate risks. Well, if you can tell a clear story of why you need that, you're more likely to get that additional budget. These are often created through brainstorming sessions where you think, what if this person decided to attack our system? So here's an example. As a malicious hacker, I want to steal credit card information so that I can make fraudulent charges. So, as an architect or developer, I want to verify that sensitive data is kept restricted to actors that have authorization. So what's my requirement elicitation? Implement security for user information. This is almost a textual way of doing what we saw graphically with use cases and abuse cases. Now here we just see an example of 4 different abuser stories, and we complement those with 6 different security stories. So we look at what the bad guys might do, and that helps us identify mitigation steps. This is a theme you've seen throughout these lessons, and it will continue to permeate the course. How effective are these things? Well, again, we're looking at both requirements elicitation and analysis, and you can see that these sorts of stories provide a high level of effectiveness in both processes, and they're not very difficult to support. We see that continued on this screen here, where we can see some specific examples that these use stories from abusers or security help provide traceability, they provide some level of scalability, and they also make it easy for everyone to understand what we're talking about. What are the advantages and disadvantages? Well, let's talk about abuser stories. Advantages are they identify the characteristics of the system when under threat. and they help identify flaws or gaps. Disadvantages. Some people only like to use these in an agile process. Now, that's not absolute. You can certainly use them in any process you like, but they were originally designed with more agile development in mind, but of course you can apply them anywhere. You can't completely secure a system using only the abuser stories approach, and it's not meant to be comprehensive. It is meant to guide you to at least getting the major things covered in your security requirements phase. Let's talk about a specific model, Security Quality Requirements Engineering, or SQUARE. First of all, quality has been a big topic throughout IT for a number of years. We want to make sure that we're not just making software that works, but we're making really good quality software. This SQUARE model was developed at Carnegie Mellon University. They're very much a prominent figure in cybersecurity and in software engineering. It gives a means for eliciting, categorizing, and prioritizing all the security requirements. And the methodology is focused on building security concepts into the earliest stages possible of the entire development lifecycle. So we look at the effectiveness of SQUARE. How effective is it in requirements elicitation versus analysis? And you can see here, it's actually pretty effective in both areas. It provides for the dynamics of an elicitation process that's iterative. It provides for removing ambiguity, and it's useful in internal and external analysis. We follow through on this screen with more examples of how this SQUARE model can be used both in specification and management. The process. First, agree on some definitions. What are your terms? One example is to use IEEE or other standard definitions. You can use focus groups to come up with definitions, and you get stakeholders and requirements engineers to participate, and you come up with a list of definitions. Now that may sound odd, but for example, defining the difference between a virus and a worm. You ask 3 different security people, you may get 3 different answers. So let's define our terms for use in this process. Identify assets and security goals. What are the specific assets you're trying to protect, and what are your goals? And again, they have to be realistic. You can't simply say, I want everything to be perfectly secure, because that's not likely to be doable. Develop artifacts to support security requirements definition. Misuse cases, scenarios, templates, any sorts of thing like that. And then perform a risk assessment. What are the risks of these misuse case scenarios? Are they very likely? If they do happen, how bad are they going to be? That sort of thing. Then we do elicitation techniques. We use everything we have so far, and we get with the stakeholders and we elicit security requirements. After we've elicited them, we have to categorize them. Is this a system issue, a server issue, a software issue, a third-party module issue? What's the issue? Then we prioritize them. What are most important? We'd like to treat all security requirements as top priority, but that's just not realistic. Now we inspect them. Let's look at this prioritized list and evaluate it. Let's look it over. There are graphs, there are reviews, all kinds of techniques you could use here, but the main focus is you take the time to inspect what you've got and see if it actually meets all the needs. Is it complete? Is it actionable? Is it doable? What are the advantages and disadvantages of the SQUARE method? Easy to understand. Very easy to understand and very inexpensive to implement. Disadvantage, well, it's kind of cumbersome doing all this, so it's usually only utilized with larger projects. Could be used with smaller ones, but you may not really have the time for it in a small project. Let's look at another model. Operationally critical threat, asset, and vulnerability evaluation, also called OCTAVE. OCTAVE is an information risk evaluation strategy. It's a method to look at your risk factors and determine what are the highest risks and rank risks. There are phases of it, 3 of them. Phase 1, simply identifying the asset. Phase 2, evaluating and identifying vulnerabilities. And Phase 3, drafting security strategies and plans. And again, we see a chart here where we can look at the Octave effectiveness being implemented during requirements solicitation versus requirements analysis. And we can see that it can be used in both areas. In some aspects, it's more effective in one area than the other. And you see more of those options here on this particular screen. What are the steps? First of all, just identify your important and valuable assets. What is it you're trying to protect? I think most programmers are already aware that the hardware is not as critical as the data on it. But which data is most important? Then determine the security objective for those assets. Now the problem here, the reason we have to have specific objectives, is that security and usability are always in conflict. I can make something terribly locked down secure-wise, but then it won't be very usable. I have to find a balance where it's usable enough by legitimate users and secure enough from illegitimate users. Identify and analyze the threats and risks involved. What are the specific threats and risks to those specific assets? And then you can determine security requirements for those identified threats and risks. Advantages, really easy to use and is really good during security elicitation. Disadvantages, Octave is a little more complex than Square or some of the other things we looked at, and it doesn't really give you a detailed explanation of any quantitative analysis. It's more qualitative. That doesn't mean you can't use it. It just means that it's not the perfect solution for every situation. So what have we talked about in this module? First of all, specifying what a software should not do. This negative requirements is the essence of security requirements. Security is always a negative thing. I don't want these things to happen. Gathering security requirements should be a part of the strategic application development process. You're going to have to elicit these. Now, this is true for normal software requirements gathering. You have to elicit. Don't expect people to just produce them. And that's why we presented you with several different methods that could assist in that. These need to be enumerated separately from the functional requirements. Now, we saw places where gathering them together may be okay, but they're enumerated separately. Security requirements engineering gives the requirements gathering process more structure and more effectiveness. In conclusion, what you really want to ensure you do is that you're using all the tools that are appropriate for your project and available to you to gather security requirements, make sure they're complete, make sure they're actionable, make sure they're realistic.